Hi, this is Peter with CalcBook, and today we're going to be doing a short video focusing on foundation sliding. So, quick recap here. For sliding of a foundation, we use ASD loading, and our sliding resistance is due to the combination of passive soil pressure, so the soil pushing back against the foundation as it tries to move, and then the friction or cohesion, so the friction beneath the bottom of the footing and the soil below it, or the cohesion. So when we look at these two items, right, we typically get these values either from our geotechnical engineer or the presumptive load-bearing values from the IBC tables. So for friction, right, that's just the dead load times the coefficient for your material type there. And then if you're using cohesion, it's the contact area times the cohesion value. So for material class 5 there, they give you a cohesion value of 130 psf. Now there is one catch here. For cohesion under 1806.3.2, the lateral sliding resistance shall not exceed 1/2 of the dead load. So when you're using cohesion, you just need to make sure to include that check as part of your sliding resistance. And the last thing that we'll note here is in 1806.1, they do allow you a 1/3 increase over the values provided in this table for loads that include wind or earthquake. So let's take a look at our example here. We are going to determine the sliding stability of a spread footing. It's got dimensions of 8 feet by 8 feet by 1.5 feet deep. It has 1 foot of soil over it, and we are going to include the top 1 foot of soil in the passive pressure. This is usually determined by your geotechnical engineer. Typically, if you have some sort of containing material like a concrete surface or something like that, you can include that top foot. Otherwise, if you have open soil, you typically ignore the top foot of the soil in your passive pressure. We're going to assume the material class 4 from the IBC tables, and we have a dead load of 20 kips vertical and a lateral sliding earthquake load of 15 kips. So let's go ahead and open up CalcBook, and we'll get started on the design. All right, I've got CalcBook open now. We've already got our foundation module open, so we're just going to walk through the inputs, a summary of our inputs here. We are going to include our footing and pedestal weight. We will include the soil weight. We are checking for sliding. I've turned off the overturning calculation just to simplify the output a little bit. Our lateral loads are due to seismic or wind. That has to do with that 1/3 increase we talked about. We are including the top 1 foot of soil, and we are going to be checking against friction because our class 4 material has that friction coefficient. Our footing is 8 feet by 8 feet by 1.5 feet deep. We have 1 foot of soil above. And then our pedestal dimensions don't matter too much. And then we'll double check our soil properties here. So we've got that 2 KSF bearing pressure for dead plus live, and then 1/3 increase for lateral for total. We have our lateral soil bearing pressure for dead plus live of 0.15, and then we have our total, our wind or earthquake at 0.2 KSF per foot, that 1/3 increase. And then our sliding coefficient of 0.25. So if we take a look at our sliding calculation, we are first going to calculate the total height of the soil we have of 2.5 feet, which is the soil depth plus the height of the footing. So that gets us the height from the soil all the way down to the bottom of the footing. Then what we want to do is figure out what the pressure is at the top of the footing here. So what this pressure is here at the top, and then also the pressure at the bottom, because we only consider the passive resistance against the footing itself. We do not include the pedestal. Then we calculate our friction, right, our coefficient times the total dead load. And then we add those together and we get a 10.6 kips of resistance. Now we already saw in our design summary here that our sliding is over capacity by about 1.5. So we can do a few different things to increase our sliding resistance, right? We can increase our footing dimensions. That will give us more surface area against the passive pressure. And if that's not enough, right, we can go up a little bit in our thickness, and that should give us some more surface area against that passive pressure as well. So that is a quick overview of sliding in CalcBook. We hope you enjoyed the video, and we'll see you next time.